Welcome to Spring LIB.
So we're trying to find the distance that it must fall on Mars in order to reach the same amount of kinetic energy, and then the velocity on Mars. So we have the mass of this. So we have 15 kilograms, and then we have the delta y of 5 meters. We have a rotational kinetic energy of 250.0 joules. And then we have the gravity on Mars, 3.71 meters, rather the acceleration due to gravity on Mars, 3.71 meters per second squared. At this point, we have the law of conservation of energy, and this we should specify that this is on Earth. So we have the law of conservation of energy, the rotational kinetic energy plus the translational kinetic energy should equal the gravitational potential energy. And at this point, we can say that the kinetic energy translational is simply going to be equal to GPE, which is equal to mgh. So this would be mgh minus the rotational kinetic energy. And we should find this and say 15, 9.8, 5 minus 250, and this is going to equal 485 joules. So this is the translational kinetic energy, and we were able to find it on Earth because we have all of our givens on Earth, and then they're saying how far must it fall in order for it to have the same amount of translational kinetic energy. So we should say that the kinetic energy translational plus kinetic energy rotational equals GPE, and this time we should say mgm hm. So this would be mass times the gravity on Mars times the height on Mars, where we're trying to isolate this variable. How far must it fall on Mars in order to have the same amount of translational kinetic energy? And we find that H sub m equals Ke trans, Ke rotational, divided by mg sub m. And this is going to be equal to 485 plus 250 divided by 15 times 3.71. This will be 13.2 meters. So this is how far it has to fall. This will be our answer for part A. For part B, it's asking us what's the speed. So we know that translational kinetic energy is equal to mv squared over 2. So that means that v is simply going to be the square root of 2 times the translational kinetic energy divided by m. This would be, again, 2 times 485 divided by 15, and v is going to equal 8.04 meters per second. So this will be your answer for part B. And that's the end of the solution. Thank you for watching.